Good afternoon, everyone. We are Group 18, and my name is Apratim Viraj Singh. And I, on behalf of our team, would like to present to you our Senior Design 1 production phase project entitled An Autonomous Surveying Vehicle. Here's my team members. From left to right, we have Mr. Momin Al-Mahayani, Mr. Med Salame, Mr. Ayub Kilestimur, and Mr. Mohammed Salahi. Well, I think it comes as no surprise to anyone in this room that we are living in the age of automation. It's inevitable. And because of this, automation surveying vehicle has become increasingly important in recent years. And you may ask it, why is that important? Well, picture a scenario, picture a hazardous environment. It could be a volcanic crater on the surface of Earth. It could be a surface of Mars, for all I know, or it could be a nuclear waste disposal site, for that matter. All of those areas require a vehicle that can navigate autonomously with as less human intervention as possible, and it would be able to navigate and provide location of its environment. So all of these require vehicles that can move by themselves and gather information from the surroundings to map the region. To help navigate the vehicle autonomously, that's our overarching goal for the project. We're going to do it in a way that will get the vehicle on its destination in an unstructured environment while avoiding obstacles and at the same time creating as accurate of a 2D model of the environment as possible. So how do we do this? Well, we're going to create a model of a modified surveying vehicle, and as it moves around, it's going to collect data, object and location data, and it will perform a simple two-dimensional mapping of its environment. The primary sensors we're going to use are going to be sonar-based ultrasonic sensors. The objective can be categorized in two broad steps. First, it will obtain the shape of the room surveyed for up to 1 foot accuracy for every 100-foot square of the area surveyed. And second, it's going to obtain the location of each object over 2 inches in height. Now, once it accomplishes these two objectives, it will then relay its information to the user in a detailed schematic readable format using a Unity simulation engine on an iPhone. So since it's still in a development phase, we've identified our product development approach, and it has 3 broad steps. First step will involve calibrating the sensors and developing the object avoidance algorithm for mapping. Second step is going to involve programming the microcontrollers to analyze the received data and setting up the route parameters. And the third and final step is we're going to be able to assimilate the data through an iPhone and its GPU processor using a Unity simulation engine. And then we're going to, at the very end, we're going to convert it all into an app. And this is the final step, I think, is the highlight of the project, because there's a lot of designs out there that we've looked at. Automation is big these days, so corporations and universities are working on it, but none of them have tried to create an app that integrates the design into a mobile application. And I think this aspect of it is the one that I'm looking forward to, and we're extremely proud of.
Any questions?
So for the control system design, what are your plans to keep this thing from getting locked up in a quadrilateral room that has an egress door like this?
So basically we can set a limitation where it can actually surveys like 100 feet and then return to base, such kind of program. We're going to have a velocitor, and the way we set the sensors into X, Y, and Z, like it's going to be the obstacles will be measured based on angle and distance detected off the 3 different sensors located on 3 different sides of the car. So that will help us get the car away from getting lost.
What type of a vehicle? Would this thing look like a 4-wheel drive vehicle with big tires, or what?
Basically, we have made a small ATV.
Okay.
It's a 4-wheel, 4 DC driver's gearbox. It's 4 motors. It has 4 motors, 2 motor drivers basically connected to the Arduino circuit.
It's not clear to me from the presentation exactly what you're going to build and exactly what you're,
Basically,
what
we're,
you're proposing, you know, what is the test, what is it, what are you gonna see if it,
okay,
what-
so
what's
basically,
the success criteria?
basically this project is to build a car and let it drive itself away in the room,
The surveyor room.
surveyor room.
So you're gonna build a car, turn it loose in a room, and come back with a map on your phone.
With a map
of
on
what
my
it
phone.
is.
And there's a lot of applications we had in mind, but for this project, we have put the success as it surveys the room and define the obstacles, map it out, and send it to the application.
So is the target more to physically build a surveyor drone, or is it to, like, as you're alluding to, create an app that allows you to pull that survey data out of it?
It's both.
The app serves as a supplement to the main design.
Basically, we're working on the shield, wireless shield, to the app and the surveying vehicle. The application, you can imagine how drones are hitting trees right now and failing to distinguish obstacles. You can easily implement our design to any type of vehicle. It's not limited to only to cars.
All right, thank you very much.